Greetings all. We're going to watch a short video from lessons 1 and 3 of chapter 2. This is our introduction into polynomials. So here are some of the learning targets we'll look at in this lesson. This video is going to cover the first three. Just can we determine what a polynomial is, some terminology that goes with it, and then also can we figure out what the end behavior would be for an equation. So this is going to look really gross to start off, but when we think of a polynomial function, it's going to be something that looks a little bit like this, but we need to know what this language means. So first thing, n is going to be a non-negative integer. It's going to be something like 0, 1, 2, 3, 4, 5. And if you look at this, this is our power or degree. If this was a power of 5, we might have another part that's a power of 4, so on and so forth until we get to a power of 2, a power of 1, and then even here, maybe a power of 0, x to the 0 power would just be 1. Okay, the function would have degree n. That is the number that is the biggest, way on the left side there. All these other things, these are coefficients. There's going to be other numbers as well, but we can label them this way so we know what coefficient goes with what power. So if this was a power or degree of 5, we would call this a sub 5. The actual number in a problem might be something like 11 or 15. That's the coefficient, but this could be a way that we sort of label it. And then the a sub n, the one that goes with the largest degree, that's what we call the leading coefficient. So if we looked at the example that's on the bottom, I don't believe this is on your note sheet, but you could certainly write it in if you wanted to. When we start thinking about some of this terminology, here are some things that we know. Okay, we know that the degree is 2. That's the highest power that we see there. And we know that the term that goes with it, the coefficient, is 3, so we can call that a sub 2 is 3, kind of describing these parts here. A sub 1 is 8, a sub 0 is 5. Power of 2, power of 1, this could be x to the 0 power here, just invisible because it becomes 1 in the end. So what I'd like you to do in the examples here is just pause the video for a second and try to figure out which ones are polynomials and which ones are not. And then if they are, tell me what the degree is and what the leading coefficient is. And for those that are not, give me a reason why. So pause the video, try and figure those 4 questions out, and then I'll slowly reveal some answers here. Okay, for the first one, the degree is 3. That's the highest power right there. The leading coefficient is 4. Okay, this one would not be considered a polynomial because it has a degree that is negative, and the rule says it's got to be non-negative. Okay, for this one, our degree is 4. The leading coefficient is 9. And then part D, a little tricky there, but the degree is actually 4. It's not in standard form, really. This should go above or in front, and the leading coefficient would be negative 2. Again, this symbol right there should be part of the 2. So that last one might have been a little tricky. Okay, so what are some things that we could do as far as what's going on either side? This is kind of looking at that end behavior piece. And you might remember this from a previous class, and it's okay if you don't. But one thing that we could do, we could look at some patterns, and I'm not going to do that right now. I can certainly show you some in class if you want. But if we notice that the degree is even, that's the highest power. If that's an even one, what we're going to notice is the polynomial does the same thing on either side on the ends. Okay, if that coefficient that goes with the highest degree is positive, then on the left side and the right side, it's going to go up. And if that coefficient is negative, then both will go down. Now, if there's an odd degree here as the highest power, then it does one thing on one side and the opposite on the other side. So when that coefficient is positive, on the right side it goes up, and on the left side it goes down, and then it just reverses when that coefficient is negative. That may be something that you've noticed before when you were graphing these sorts of things, and we will look at that a little bit more in class if we need to. So what we're going to do is just quickly try to answer this question using limits, and then we'll describe it in words as well. So if we look at this equation here, I notice that the degree is 4. Okay, so that means on both sides it's going to go up or it will both go down. And since that leading coefficient is 2, it's positive, they would both go up according to our chart. So I could write this down. I know this is going to be kind of weird, funny language, but on the right side, as x goes to infinity, the y values are also going to infinity. You could also write it this way. Okay, they're going up. Y values are getting bigger. And I could write the same or something very similar here for the left side. As we look on the left side of the graph approaching negative infinity, the y values are going to infinity. I could also write it this way. So that's as far as this video is going to cover. Jot down any notes or any reminders, any questions that you have, either in your notes or at the end of this video, and we'll see you in class.